Hello kiddos, hope you're doing well. I wanted to introduce a little different way to organize these word problems for the use of a table. And I think this might be a little bit easier for some of you, instead of kind of framing it abstractly. So here's the basic idea, right? And it works for distance, rate, and time. It also works for a coin problem. So I want to show you two different ways of solving the same problems that I showed you how to solve from the previous video, just using this table. So what I'm understanding is that distance is rate times time. So if this column is distance, then rate and time are here. So whatever Abby's rate times her time is going to be equal to that distance. Okay, and then this row I have the total. Okay, so here's the problem. If you recall, you have two classmates. They're working in opposite directions, and they travel for 4 hours, and then they're 480 miles apart. Right. So we know this is Abby is 10 more than Dennis's speed, and we want to find both their speeds, right? So if we're looking really for rate, speed is rate, miles per hour, right? So if I call Abby's rate, or actually let me call Dennis's rate x, right? And therefore Abby's rate is going to be 10 more than that, right? X plus 10. We know they're both traveling for 4 hours, and we know at the end of the day the total distance is 480. Okay, so here's what I'm going to do. I'm going to multiply rate times time to get Abby's distance. So it's going to be 4 times the quantity, x plus 10. And Dennis's rate times time equals distance will be 4x. Okay, so at the end of the day, we have Abby's distance plus Dennis's distance equals the total distance, right? So therefore, our equation that we want to create is going to be Abby's distance, rate times time, plus Dennis's distance, rate times time, equals the total distance. Right. So we're kind of adding this column up to get the total distance. Okay. Let's see how that, and you guys can take it from there. Let's see how this works in a coin problem, right? Because you have a similar idea where we have a vending machine, we got some coins in it, 225 total. And instead of rate times time, that doesn't really make sense. But in this case, we have quarters, and we have dimes, and we have the total as well. But we don't have rate and time anymore. We have, I guess, worth, and we have number of those, and that gives us our total value. All right, so what I would like to do is kind of start fresh here using the same table and a similar idea, kind of see how we can use this table to solve this particular problem. So what I'm going to do is we have 225 total coins, right? Quarters and dimes, right? So if I have x quarters, I have 225 minus x dimes, right? So that's the number of dimes, quarters that I have, right? Because they have to add up to be 225. Okay, I know quarters worth 25 cents, so I'll call it 0.25. I know a dime's worth 10 cents, so I'll call the dimes worth 0.10. Right, and I know at the end of the day, here's my total, right? So the total is going to go down here, 38.70. Oops. Okay. So now, in the similar way we did the last table, right? This column was rate times time to get this column. And this column here, I'm going to multiply the worth times the number of quarters to get the total value of quarters. So it's 0.25x. And then the total value of dimes is 0.10, the worth times the number of dimes we have. And this, the amount I have in quarters, plus this, the amount I have in dimes, is going to be equal to that, the total amount. All right, so my linear equation that I'm going to create is 0.25x plus 0.10 times the quantity, 225 minus x. And that has to add up to be the total, 38.70. Okay? And you guys can solve from there. So hopefully you think this, for some of you might find this to be helpful. Try this with the other problems if it helps, and let me know if you have questions. Bye-bye.